final workshop. So I'm going to go ahead and help you with Alex. Let's jump over directly to Alex. Again, I recommend that you bring Alex up on a different device right next to here, and you go through each one, pausing what I do, and go ahead and working the problem. You can work through what I'm going through on paper to make sure that you're able to solve it, rewind it, pause it, have it together, and then if you have questions, you can go ahead and send me an email or something like that, and I can try to clarify what your problem is. Okay, let's go ahead and look at the first topic is classifying systems of linear equations from graphs. So we're just going to identify what type of systems of linear equations they are. So let me just go through the type of systems we could have. Well, we have, first of all, system A, you've got two lines that cross at one point. System B, you've got lines that do not cross at all. And then system C, you have what appears to be one line, but what it actually is two lines sitting directly on top of each other. Okay, so we're going to go ahead and look at these different particular things, and you can see that the first one, system A, has a line, has a point, and so because it crosses, that is called consistent. So the fact that it has at least one solution, we call it consistent. They are independent because they are two separate lines that just kind of happen to meet at one spot. Just reminds me of East and Main Street. East runs north and south, maybe Main runs east and west or some sort of aspect of that, and they happen to cross right there at East and Main, but they're two independent streets completely. System B is called inconsistent because they do not cross anywhere. Remember, to be consistent, it has to have a solution. So those are called inconsistent because they're parallel lines, so therefore they never have a solution because a solution is where they cross. So railroad tracks, we don't want to have a solution. We don't want them to cross, but that's why it is inconsistent because there is no intersection point. Finally, system C, they're consistent because they cross. Where do they cross? Everywhere. Well, it has to be the same line, so we call them dependent. So in order for them to be the same line, they're dependent because if line 1 has a 3, 4 in the solution, so does line 2. If line 2 has a solution of maybe the point 10, 7, then line 1 also has to have it, so they're dependent on each other. So remember, consistent or inconsistent means if it crosses or doesn't cross. So consistent means cross, inconsistent doesn't. And dependent, independent means if it's the same or separate lines. Solving a system of linear equations using elimination with multiplication and addition. Okay, this is honestly, I love elimination because it really simplifies the problem very, very nicely and then allows me to solve it pretty quickly without a lot of trouble. So let's look at here. The whole idea of elimination is I'm going to eliminate either an X or a Y. So we're going to eliminate X or Y. So to eliminate it, I have to have them be, I'm going to be adding these two equations together. And so if I have 4x on one equation, I need negative 4x on the other equation. So when I add them together, it gets 0. So they eliminate each other. So I'm going to go ahead and look at these. I have 5x minus 6y equals negative 6. And I'm just going to change colors. And I have negative 8x plus 7y equals 20. Now let me tell you, you can choose X or Y, doesn't matter. Whichever one you want to eliminate, you can absolutely choose X or Y. Doesn't matter. This one, honestly, it doesn't matter. Sometimes it's easier to choose X or Y, a particular one, because you only have to multiply. You have to multiply less. But on this one, there's no common multiples, so we're just going to look at it. I'm just going to randomly choose X. And I'm going to go ahead and make those equal each other. Well, how do I make them equal each other? Well, the way we're going to make them equal each other is similar to doing like a common denominator. So I'm just going to really make it easy and multiply everything on top by 8. So, and then what happens when I do that? I get 40. Well, let me make it green again just so we know which one is which. I'll just make it a little bit darker green just so we know that's one. This is it multiplied out. So 8 times 5 is 40x. 8 times negative 6 is negative 48y. And 8 times negative 6 is negative 48. So now what am I going to do on the denominator? I'm going to multiply it by 5. Because 5 times negative 8 is negative 40, and there we go. That's going to be close to what I need to, that's going to be, not close, but it's going to be exactly what I need to do. So 5 times negative 8 is negative 40x. 5 times positive 7 is positive 35y. And 5 times 20 is 100. Let me stop a second and talk about what we did and why we did it. Okay, so my purpose, remember, is to eliminate either x or y when I add the two equations together. So in order to do that, I'm going to have to manipulate them so that they have something that is absolutely the same, which I did right here. As you can see, I have a negative 40 and a positive 40. So you can choose to do it to x or y. Doesn't matter. I chose x just because it was the first one listed. And in order to do that, I'm just going to multiply the top equation by the number down here and the bottom equation by the number right here. Now, I did not do it by negative 8 because I need them to be opposite. Okay, I need them to be opposite. So I just multiplied by positive 8. So that's the whole purpose of why I did what I did, that I needed to eliminate x or y. When I add the two equations together, they will get 0. So these two eliminate, and I end up with negative 48 plus 35 is going to be negative 13y, and this is going to be positive 52. Okay? Now when I divide negative 13 on both sides, I get y is equal to negative 4. So I have y equals negative 4. What I need to do is take this guy, plug it into either this equation or this equation so that I can get my x out. I'm just going to choose the top one just because it's first. So 5x minus 6 times negative 4 equals negative 6 plus 24 equals negative 6. Subtract 24 from both sides, and 5x equals negative 30. Divide by 5, and x equals negative 6. My solution is going to be negative 6 comma negative 4. It would not matter if I put it in the top equation or the bottom equation. In fact, I always encourage my students to put it in both of them just to make sure you get out the same answer. If you didn't get out the same answer, you did something wrong. Go back and check your work. All right? So again, let's go over the steps one more time. So the whole purpose is to eliminate x or y when I'm adding the two equations together. So I'm simply going to take this number and multiply the top equation and this number and multiply the bottom equation. Remember, I'm trying to get them as one is positive and one is negative. So if I need to multiply one by a positive and one by a negative, or both by negative or both by a positive, then I do so. But that's where the numbers come from. Second step is I go ahead and add them together. Third step is I go ahead and solve for my y. And fourth step is I plug in my y to either equation to solve for my x to get my answer. Okay, solve a word problem involving sum and another basic relationship, including the system of linear equations. All system of linear equations means two equations or more. So it says the sum of two numbers is 41. The larger number is 13 more than the smaller number. So I'm just going to translate it. When it says sum of two numbers, that's x plus y. So that's exactly what we did here. X plus y equals 41. Then it says the larger number. So let's say, okay, let's have x be the larger number, is y plus 13. Once we have that, we're going to go ahead and plug in y plus 13 for x, as you can see we did here. And we solve for y equals 14. Graphing a system of two linear equations. So this here, not equations, these are inequalities. Inequalities means not equal to, which means a less than or a greater than. but not an equal to. So we're going to graph these as if it's an equal sign, but then we're going to shade them based on their sign. So that's what I'm going to try to help you with. So this particular one, I'm going to just kind of keep coming in and out. All right. I just want you to see less than. So everything is less than. That's how I try to kind of remember. But if it's less than, then it's on the lesser side. So that would be a less than, or I guess this would be a less than or equal to. A less than itself, this is less than or equal. This is a less than. And that would be if this is dotted. Or let me just do it in a different direction so you can see that it's the same thing. Let's do this. And what's the lesser side? These are the lower numbers down here. So that's why it's less than. If it's greater than or equal, that's a greater than or equal. It's going to have a solid line. Let me go ahead and just change colors. And it's going to be everything on the higher side of the line. The numbers are higher up here. And then just a greater than is going to be, oh, let me just change it. It doesn't matter. Let's say it's like this. Doesn't matter. But where the higher numbers are. So on the higher side of the line. So that's how you know which side to shade. So for this one, y equals 2x plus 3. First step, graph at 3. Go up 2 over 1. And it's a less than sign. So it's not a less than or equal to. So that's why it's dotted. So that's why you see the dots. And because it's less than, remember, it's where the lower numbers are. Lower numbers are underneath the line. Higher numbers are above the line. Let's just kind of walk through these. And then the other one is greater than or equal to. So you're going to start with graphing this at -6 because that's the y-intercept. The slope is down 5 to the right 1. So I'm going to count from -6 down 5 to the right 1. Solid line. It's greater than, and so you're going to have to put it on the right side. So the solution is the overlap. So I'm going to put them on one graph, and you see the dark area is the solution. And with the ALEKS tool, you can go ahead and make sure you unclick the light areas, and you only are going to want to click that dark, this one area here, otherwise they'll count it wrong. Because if you keep it like this, you have to make sure that you indicate the dark area is the one that is what you're looking for. All right, so this is very similar to what we just did. In fact, it's identical. So I'm just going to skip over this one. It's the same identical. Solving a tax rate or interest rate problem using the system of linear equations. All right, so first of all, it says last year, Raina had $30,000 to invest. That's a lot. That would be nice to have $30,000 to invest. That's good. So she invested some into an account that paid 9% simple interest, and the rest was 6% simple interest per year. Okay, that's good. And then after 1 year, she received $2,400 and I can't speak, can I? $2,430 in interest. How much did she invest in each account? Okay, so we're going to say, well, I know that she invested and got 9% in one account and 6% in another account, and it told me just in interest alone, she got $2,430. So I have my equation already set up that we know that both accounts were a total of $30,000 before investing. And we know that the interest is 9% plus 6% is equal to $22,430. So now that we have these, you can substitute. You can do this in lots of different ways, but what we're going to do for this one is we're going to say, okay, I'm going to take this, but that's equal to X. See, I'm going to subtract Y from both sides. So that's where we got the 30,000 minus Y. Or actually, they solved the other way, which we could do as well. I could have done that. That's what the publisher chose to do, to have subtract X from both sides and have X plus Y equals 30,000. and subtract x from both sides, and you get the same thing here. So either way, it doesn't matter. But what you're going to do is you're going to say, okay, hey, look at this. Y is equal to this, so I'm going to put that in for y. And then you're just going to do a little bit of algebra and solve for your answer. Okay, we're going to do something really similar now, except this time is with mixtures. Okay, so this here, we have two things. We're going to first of all talk about total number of tickets that were sold and then profit that we got. So the first thing, it says I've got two types of tickets. I've got advance and same day. So I'm going to have X be my advance and Y be my same day, and I sold a total of 60 tickets. So I have X plus Y equals 60. But then for every advance ticket, I got $35. For every same day ticket, I got $40. Total profit, or excuse me, total revenue there was $2,200. So those are my two equations. So to solve these equations, same way we just did the last one, that we're just going to substitute. So I'm going to say, okay, here, So I have y is equal to 60 minus x, or x is equal to, that's the way the publisher did it, or you could have done x equals to 60 minus y. It doesn't matter. It just is going to determine where you plug it in. So I have 60 minus x, and I'm going to plug that right into y, just like we did here. Solve it out, and boom, we get x is equal to 40. Plug that back into the original equation, and you get y is equal to 20. This one is a percent mixture problem. So the percent mixture problem is the difference is, remember, it equals 100% total. And so that's going to be your the total aspect of it. So when we have 1% is 45%, and then we're going to, we know the other percent because of just a simple percentage problem. So let's look here. The easiest way to do for this is say, okay, it tells me I have, I don't know my water, I don't know my salt, but I do know the total mixture is 135 in ounces. We're in ounces. So x plus y is equal to 35. And honestly, this is kind of what I always show my students is like, okay, well, there's my equation right there. X plus y equals 35. And right here, I have my second equations because it says, look, I don't have any water. I don't have any salt in my water, but I have 45% salt solution in my salt. So I have 0.45y, and that's 47.25. So now those are my two equations. Once you have your two equations, then you are able to solve the same way we just did, and we're going to, well, I guess the way they did this one is a little different, but same idea. Since they're going to use 0.45y equals 47.25, and the same thing, it's like, look, I got an x, I got a y, and so it's doing it saying, hey, look, right here. So it's dividing both sides by 0.45 to get y is equal to 105. So now it's going to substitute that right smack into this original equation to get 30. Because you don't have to go through solving everything back and forth because you have y right away. So that's nice. Let's see, which one are we on? Graphing a linear inequality in a plane, vertical or horizontal line. Okay, so this is very simple because remember, as I said, greater than are the bigger numbers, less than are the smaller numbers. And simple, x is greater than -7. Where are the greater numbers? To the right. That's where all the bigger numbers are. And it's dashed because it isn't greater than or equal to, it's just greater than. Okay, so just this is interpreting a graph. So you see Sam's car is going to, gas remaining is decreasing as the miles driven. Same with Jose's car, but Sam's car's got a lot less gas mileage because it goes down a lot quicker. And Jose's car is a lot better gas mileage because it goes, you can make a lot further in less amount of gallons. So which one has at 150 miles driven. So you go to 150 and you say, okay, which one has more gas in it? Well, Sam's car does, but it has a bigger tank to begin with. It just uses a lot more gases. You know, it's a truck versus a little tiny Honda Accord. Well, the Honda Accords probably have a little bit bigger tank than 12 gallons, but it's the same idea. After how many miles will the tanks contain the same amount of gas? Right there at the intersection point is 300,7. So after 300 miles, and the tanks will both have, oh, not 7, sorry, that's a 6 gallons. And that's it. Let's interpret the graph of two functions, just like we did before. Same idea. So I'm going to skip this one. Actually, I definitely just did that one. Graphing a linear equality in the plane, slope-intercept form. All right, so for this one, you're going to graph it. We just did this one at the beginning of the lesson. If it's greater than, you're going to shade above. If it's less than, you're going to shade below. If it's a greater than sign or a less than sign, it's dotted. If it's a greater than or equal to or less than or equal to, it's solid. I think I keep clicking the same one got clicked. All right. Okay, solve a system of equations by graphing them. So you're just going to put them into y equals mx plus b equation, and then you're going to graph them. Now, as this is showing you, when you have one solution, it crosses one time. When you have no solutions, they do not cross and they're parallel. And when you have infinitely many solutions, you literally have the same line. So this particular one, when you graph the first line and graph the second line, you're going to say they're the same line. So that's infinitely many solutions. Okay, substitution. You've actually done substitution a couple different times already in my lesson here. But what you're going to do for substitution is you're going to make the easiest way that you can solve for x or for y and then put it into the other equation. So we're going to isolate. I would do the bottom one I would do for x because it looks like it's the easiest to get by itself. So that's exactly what the publisher does here, and it solves it by putting adding 3y to the other side. And I get 17 plus 3y is equal to x. Now it's going to take that and put it into the opposite equation that's showing you here in red, and then solving it through by distributing. That's where negative 3 times 17 right here gets you negative 51. Negative 3 times positive 3 is negative 9y. And then simplifying a bit to get y equals negative 4. Once you have that negative 4, then you're going to go ahead and put it into either one of the original equations and get what your x is. Same thing, we just did another elimination. This is an elimination problem. For this one was kind of one of the ones I said, you don't have to multiply the top and the bottom by something, because if I multiplied just the top by negative 2, then look, negative 2 times 3 gets you 6, negative 6, and it's already at the opposite. So I'll just run through that for you because I think the publisher does it a little bit differently. But for the system, remember the whole idea of elimination, if I'm doing elimination, the whole idea with elimination is that I'm eliminating one of the variables. So in order to do that, I need these variables to be the same, or these to be the same. These already are the same, so why don't we make it easy for us and do what they did here and just multiply that bottom part by negative. And so then look, I have 3x minus 6x, and I have 4y minus 4y. And so those just cancel so nicely for me. And I get 3 minus 6x is negative 3x. And I get this is negative 12. Divide by negative 3. And I get 4. So that's kind of nice. Oh, look at that. I went one page too far. Let's see, there we go. There we go. Last one here, and I think there's two more on another tab, but let's go ahead and look at these. Then we have a party rental company has chairs and a table for rent. The total cost to rent 5 chairs and 3 tables is $25. So I have 5x plus 3y equals 25. And the total cost to rent 2 chairs and 6 tables is $40. So 2x plus 6y is 40. And then solve with any of the methods that we just did. So the particular one that I would like to do, and this one, is elimination, just because it seems like it would be the simplest to do. And so I'll go ahead and work you through that one. So I'm going to change this problem. I'm going to multiply this by -2, because what happens is this becomes negative 10x, this becomes negative 6y, and this becomes negative 50. So it's right there. So when you add them together, those guys cancel out. And go ahead and solve for your x, and then put your x back into either equation to get what your y is. All right, let me go to the other tab because I've got 2 more. Solving a distance, rate, time problem using systems. So this is, remember, distance, rate, time is rate times time equals distance. So this one is showing, it shows a fast train and a slower train. And so 4x is my distance and 4y is my distance for my slower train. But it tells me they're 744 miles apart. So if I add their distances together, it's 744. But then it also tells me the faster train travels 12 miles an hour faster. So the rate of x is y plus 12. So then you can substitute the y plus 12 in for x, and then you get out, once you solve the problems, you end up getting 87. And then solve, put 87 back into your any original equation to get what your x is. Okay, 2 systems of equations are given below. For each of the system, choose the best description. So let's look at system A and system B. So system A, when you solve it, you can see it ends up getting one solution, which you can see here. Which, by the way, to do this, you could graph it, you could solve it. I think the easiest way, let me just graph it for you, because honestly, so I have 2x minus y minus 4 equals 0. Okay, I'm just going to put everything to the other side, subtract 2x and add 4, subtract 2x and add 4. So I get negative y equals negative 2x plus 4. Let's divide by -1. And so I'm putting into y equals mx plus b form. 2x minus 4. And then I have the other one I have is just 2x plus y equals 4. So subtract 2x, and you have y equals negative 2x plus 4. Well, if you see they're 2 separate equations with different slopes, and since they have a different y-intercept and a different slope, we know that they're going to intersect in one spot. If you weren't sure, because look, one's 2x and one's negative 2x, so no matter what, if I have one going up like this and one crazy slope going down like this, they're going to eventually, intersect. They will intersect eventually. So that's how you know that they're going to intersect one time. But the y-intercepts are different, and since those are different, they're not the same line as well. So if you want to just say 1, 2, 3, 4, -4, and graph it and go up 2 over 1, you can do that. And this just might make it easier. And this is 1, 2, 3, 4, make a dot, down 2 to the right one, the way we learned. And then you can see that, look, it does have one solution, and that's it. So that's the way I would do it, but, it's up to you. You can see on this one, as soon as you do your little math, negative 3x plus y equals 6, plus 3x plus 3x. Y is equal to 3x plus 6. And let's do this one. And this one I have 3x minus y equals 6. Subtract 3x, and I get negative y equals negative 3x plus 6. divide by -1. Y is equal to 3x minus 6. So you can see here, oh, look, this is, ta-da, same slope. Same slope means I've got one here and one here, which they never cross, and so that's why it's no solution. Again, you can graph it, and you say, hey, let me just graph it because I just feel more comfortable graphing it. And so you go -6, boom, up 1, 2, 3 to the right 1, choop. And then this one is at +6, and you go up 3 to the right 1, and you go, oh my goodness, look, they're never going to cross because they're parallel. Okay, I hope that was helpful. Please let me know if you need any help, and I will make myself available as much as I can. Have a wonderful, wonderful day.